In this video, we are going to discuss the second part of the sample size, and we are going to discuss how can we estimate the sample size for this study. As we start, many researchers believe that the larger the sample size, the better the study becomes. However, this is not always the case. It's better to exert efforts to improve the accuracy and quality of the collected data rather than running after drawing unnecessary large sample size. And we will summarize the most important aspects or the most important approaches that we are using or the strategies that we are using for determining the sample size. And we can talk about the using of a census for a small population as the first strategy and imitating a sample size of similar studies. This is the second strategy, and using the published tables as second strategy, and then applying formulas to calculate the sample size, and then to use the statistical computerized packages and software for estimation of the sample size. We are going to discuss the first four strategies for estimation of the sample size, and in the coming video, we are going to discuss this, how to use statistical computerized packages and software for estimation of sample size. We can use ABM, for example, to estimate the sample size. Now we talk about the census, using a census for a small population. One approach to use the entire population at the sample, and it means that we use the whole population if the size of the population it is small, and although the cost consideration make this impossible for large population. If you have large population, you cannot use the whole population or the census for the population. But usually for a small population, for example, population less than 200, for example, you can you can use the whole census or the census of the population at the sample size. A census eliminates sampling error and provides data on all the individuals in the population. But there are definitely some problems with it. We will talk about them later. Also, we talk about sometimes we resort to total coverage of the whole population. For example, if a researcher is intending to draw all patients attending the emergency department in tertiary hospital with surgical complication, as well as fulfilling specific criteria for 2 months or 3 months, the duration of the study. So there is total coverage for the whole population. One of the problems with the using the census is that you eliminate the sampling error, but there are some problems in if the population is large, as we have mentioned. Using a sample size of similar study, another approach or other strategy is to use the same sample size as those of studies similar to the one you plan. Without reviewing the procedure employed in these studies, you may commit mistakes. You may run the risk of repeating the errors or the mistake if they're initially done by the investigator. For example, if you resort to certain article and you imitate the sample size itself and use it, but if in case that the investigator had made any error or mistake, then you are going to repeat the same mistake. So this is a risk that you have to avoid. Then we can talk about using published tables, for example, and this is very important to consider to determine the sample size, to rely on the published tables, which provide the sample size for a given set of criteria. Here we have an important reference, an interested reference, which is the article of Galen D. Israel of University of Florida. And this is very interesting, and you can see it here. And I think this is an important source that we need to use and to cite it, as you can see from the website here. You have here two tables which are so important. We are going to talk about them, how to use them. Uh, Table 1, the table showed the sample size based on the size of the population and the levels of precision and the level of confidence, 95%, and the population sizes range from 500 to more than 100,000. So you need to recognize or to know your population size and then to predetermine the level of precision as we have discussed previously. And then you can directly obtain the sample size by resorting to, by referring directly to the table. Table 1, you see, we can see that we have the population sizes here from 500 up to more than 100,000. So then you have to decide the level of precision you are interested to, whether it's plus or minus 3% or 5% or 7%. And as we know that when you have high level of precision, then the sample size will be higher, and vice versa. If you are less precise, you use 10% or 7%, you will have smaller sample size. People usually use the 5% level of precision, and then immediately, if you know the population size here, then you can easily pick the sample size as estimated. Is written according. If you have, for example, a population of 7,000 and you are interested to have level of precision 5%, then you can have the sample size is 378. Then we have also table 2 here. And here we have the population size from 100 up to 450. And here the level of precision starts with 5%, 7%, and 10%. So you need to have the population if it is less than 500. And then you have the level of precision, which is 5% or 7% or 10% as you desire. And then you pick easily the sample size. So when we talk of this, you see it starts from 5%, not from 1 or 2 or 3% level of precision, which is tallying with what you have mentioned, that a small population, for example, less than 200, you can have the whole population as a sample. This is about the published tables and how to use them, and you can find them at reference there. I have just said that you can see it in the reference of Gellin. And the two tables, you can use them according to population size. And then we go for the formula to calculate the sample size. There are many formulae that can be used for estimation of the sample size. The researcher is expected to be acquainted with such formulae and their applications. For example, in a descriptive study in a certain village, we want to measure with a certain precision the proportion of children aged 12 to 23 months who are vaccinated against measles using a simple random sampling. And the following steps are used for estimating the desirable sample size, estimating how big the proportion of those children who are immunized, for example, 80%. And such estimation is not carried haphazardly, but based rather on results of previous studies in the same area or similar area. And then we choose the level of precision you will allow in the estimate of the proportion, for example, 5. And this means that if in the study, if the study indeed, if in the study you need to this means that if in the study you need 80% of the children are found to be vaccinated, this proportion will probably be between 75 and 85%, as we have selected the 5% as level of precision in the whole population from which sample is drawn. And then we choose the confidence level with which you want to be confident that the vaccination coverage in the whole population is indeed in between 75 and 85%. You can never be 100% sure. For example, You want to be 90% or 95% or 99 as you can select. Now we discuss the commonly used formulae for estimating the sample size in descriptive studies. For example, we have here n z square pq over the degree of precision, where n stands for sample size and z is the normal standard deviation, which is 1.96, and the p, the frequency of occurrence of an event, which is zero point 0.8, for example, for the previous example. And then the q is 1 minus p, the frequency of non-occurrence of an event, which is 1 minus zero point 0.8, which is 0.2. And d is the level of precision, which is 0.05%. And then you can easily calculate the sample size. N is equal to 1.96 multiplied by 1.96 multiplied by zero point 0.8 multiplied by zero point 0.2 divided by 0.05 multiplied by 0.05, which is equal to 145 or 246 approximately. Then we have another example so that we can apply the formula. We can talk about the research intending to conduct a survey to determine the prevalence of ankylostomiasis among school children in a certain village, for example. From previous surveys conducted in the same area, the prevalence rate of ankylostomiasis was found to be 100 per 1,000, for example, 10%. How the researcher will be able to estimate the required sample size? That here is 1.96, and P, the frequency of occurrence of ankylostomiasis from previous surveys, which is 10% of school kids. In other words, the probability of having ankylostomiasis is 0.1. And Q is 1 minus 0.1, which is equal to 0.9. The probability of not having ankylostomiasis among the school children in the study area is 0.9. Thus, applying the above formula, we have 1.96 multiplied by 1.96 multiplied by 0.1 multiplied by 0.9 divided by 0.05 multiplied by 0.05, and then we can get 138 sample size as calculated. If the population is small, the sample size can be reduced slightly. For example, sample size can be adjusted using the following formula as stated by Galen Israel in his famous article. We have the formula here, formula 2, which is n is equal to n0 divided by 1 plus n0 minus 1 divided by n, where n, the capital N, the population size, and n0 is the sample size. Thus, the previous calculated sample, n0, which is 138, as we have previously calculated it, and the population, with, for example, is 1,500, then the adjusted sample size is 138 divided by 1 plus 138 minus 1 and divided by 1,500, which is equal to 126. And thus the formula is of value for adjustment, especially when the researcher is confronted with limitation of resources such as cost of time, etc. In the case the researcher could not trace the prevalence of ankylostomiasis from previous studies, and this is commonly encountered in real-life situations, the only options remain is to assume that the expected prevalence is 50%, and thus the sample size estimated as follows. Z is 1.96, and P, the frequency of occurrence of ankylostomiasis, assumed to be 50%. In other words, the probability of having a unit is 0.5, and Q is 1 minus 0.5, which is 0.5. The probability of not having ankylostomiasis among school children in the study area is 0.5. And then we can compensate in the formula as follows. N is 1.96 multiplied by 1.96 multiplied by 0.5 multiplied by 0.5 divided by 0.05 multiplied by 0.05, which is equal to 984. And another formula that can be used for calculation of the sample size at confidence level of 95% and degree of precision of 0.05, and the population size is known, quoted by Galen Israel in his famous article, and we provide a simplified formula to calculate sample sizes, and this formula was used as follows: n, which is sample size, and the total population is known for us, which is the capital N, and the D is the level of the precision. Applying the formula provided that the population size is 2,000, for example, and the level precision is 0.05, then the estimated sample size is n uh, equal to 2,000 divided by 1 plus 2,000 multiplied by 0.05 square, which is equal to 100 to 333. And these are the important formulas that we can use for estimation of the sample size. The use of tables and formulas to determine the sample size above discussion employed proportions that assume a dichotomous response in the questionnaire for the attributes being measured. There are two methods to determine the sample size for variables that are polytomous or continuous. One method is to combine responses into two categories and then use the sample size based on proportion. This was mentioned also by Galen Israel. And the second method is to use the formula for the sample size for the mean, and the formula of the sample size for mean is similar to that of the proportion, except for the measure of variability. And the formula for the mean employs the variance instead of PQ as shown in the figure here, where N0 is sample size and Z is the abscissa, and Z is the abscissa of the normal curve that cut off an area at the tails, and E is the desired level of precision in the same unit of measure at the variance, and the variance of an attribute in the population. So we need here the disadvantage of this sample size based on the mean, that a good estimate of population variance is necessary, and often such estimate is not available. So it is not commonly used by the researcher to estimate the sample size. This is the end of the session of today, and the coming session will be focusing on the use of computerized statistical package. Specifically, we'll talk about how to use the EPI info for estimation of the sample size. Thank you very much.